This is the screencast for section 7.2, example 3. This is going to be a little bit more practice. This time we're going to have some weird intersections that we need to use for our lower limit and upper limit of integration in finding area in between two curves. So in example 3 here, we've got y equals 2 cosine of x and y equals x squared minus 1. Now the directions say find the area of the region enclosed by those graphs. Well, that means it's going to be this area in between. It's enclosed by those two graphs and those two graphs only. Not out here where there's no enclosure, or out here where there's no enclosure, or up here. It's enclosed by those two graphs. So we're going to find the two intersections on the calculator as I showed you in the previous example, and then I took the x-coordinate from the left one and I stored it in my calculator as negative 1.2654, whatever. And then I took the x-coordinate from the second intersection and did the same exact thing. And that means I can write on my paper A is approximately equal to, B is approximately equal to, and that tells my grader that I'm using this value for A and this value for B, but not exactly that. The grader would know then that you're using this value that's exactly in your calculator. But don't forget to write that down if you're going to use A and B, the letters A and B, on your paper. So now, because I have what A is about and B what is about, I can integrate from A to B. I don't have to write those numbers anymore. From our top function minus the bottom function. And then in the calculator I get that to be 4.995. Then now try problem number 7. Says use a calculator to find the area of the region enclosed by the graphs of the two functions. So this time, same thing. I graphed the two functions, and I can see that the area enclosed by them is right here in the middle. Well, I got to find that left intersection and right intersection, and I did. I stored them in as my x values. Now I can integrate from A to B the top function minus the bottom function, so area of the top function minus area of the bottom function, giving me the area in between, which is about 1.670 square units.